So like I said in the previous video, it is preferable to simplify the difference quotient algebraically first, then evaluate it for particular x and h. And in the next couple examples, I'm going to show you how to do that. So the purpose of this example 4 and the next few ones are going to be to evaluate the difference quotient. And the difference quotient is going to be eventually combined with a limit to produce something called the derivative. And the derivative is just a way to measure the slope of a tangent line. And what's a tangent line? It's a line where the 2 points are super close to each other, and so the gap is very small. But we'll get to that later on. So for now, I would like to evaluate the difference quotient. So in this case, and always, the difference quotient is the same. It's f of x plus h minus f of x all divided by the h. That is the formula for the difference quotient. And so let's break it down one step at a time so that we're not confused. First of all, they want me to find f of x plus h. So what does that mean? That means they want me to go to the function f of x and replace all the x's with x plus h. So I'm going to put that into this set of brackets. And so I have x squared plus 2x, and I'm supposed to replace all the x's with x plus h. That's the very first step in the process. So all this inside the first bracket represents the first part of the problem, which is the f of x plus h. Then there's a minus sign in the middle, so I'm going to put a minus. So that minus in the middle right here is the same as that minus right there. And next they want me to write down the f of x. So again, to be careful and not make any mistakes, I'm going to put brackets and I'm going to stick the f of x into that second set of brackets. So remember, this one is f of x, so I'm going to stick it right here. What is f of x in this problem? It is literally x squared plus 2x. And they want me to divide everything by h. So that is the setup. That's how we begin the process. Now there's going to be a lot of algebra coming up next, so that's not terribly difficult as long as you're organized and you do everything kind of in a nice organized fashion. Keep track of all your squares, your minuses, then you won't make any mistakes. Okay, but the first step is usually the hardest for most people, so let's make sure you get it right. So again, the first part is f of x plus h, so they want you to go to the function f and remove all the x's and replace them with x plus h's. That's what I did on my first underlined in red bracket. Then the second one was f of x, so that means literally copy the f of x, but make sure that you remember there's a minus in front of it. So when you copy the f of x, make sure you put some brackets around the quantity. That's the reason why we have x squared plus 2x inside brackets. Now I'm going to square everything. So keep in mind that when you square x plus h, your answer turns out to be, x plus h multiplied by x plus h. And when you FOIL it, this is going to give x squared plus xh plus xh again plus h squared. That goes in place of the first x plus h squared. So x squared plus xh plus xh again plus the h squared. Next, we're supposed to multiply the 2 over the parentheses. So that gives us 2x and 2h. Next, I'm supposed to take that minus sign and give it to everybody that follows. So negative x squared and negative 2x, all divided by the letter h on the bottom. And this is not important. We could just go ahead and delete it. So at this point, you should notice that some things on the numerator will be similar to each other, so they can cancel out. For instance, the x squared minus x squared are going to disappear. They're going to cancel. Similar to that, the 2x and the negative 2x are going to cancel each other out. The things that are left in the problem all have an h in them. So if you look carefully, xh, xh, h squared, 2h. They all have h. So we're going to factor the h out. And what are we left with? Let's put what's left over inside the parentheses. From the first one, there's an x left. From the second one, there's another x left. From the third one, there's an h left. And finally, from the last one, if you remove the h, you'll be left with a 2, all divided by h on the bottom. And we do that because now the h on top and the h on the bottom of the fraction can be reduced to lowest terms and divided out. And when we divide them out, we get x plus h plus 2. which is at the end 2x plus h plus 2. And that is going to represent the final answer for now. So typically speaking, once they give us the x, let's say x is 5 and h is 3, we just plug them in here and we are able to calculate the difference quotient super fast. So, going back to that problem earlier, we had x equal 5 and h equal to 0.1. So we can now plug them into the formula right there, and boom, we have the final answer super fast. We don't have to do separate calculations anymore. And we can use that formula again and again with different x's and different h's.